In our previous lectures, we have seen how to find the complementary function for any given higher order differential equation. Now, in that, we have already covered three different types of complementary function. The first type was when the roots of the given auxiliary equation are real and distinct. The second type was when the roots are real and repeated. And the third type was when the roots are imaginary. Now there is one last type left in which we have to find the complementary function when the roots are irrational. Roots are irrational. Now people, the very first thing that you need to know is what do you mean by the word irrational. When I say roots are irrational, so the first thing that should come to your mind is what is an irrational number. I hope many of you already know that root 2 is an irrational number, isn't it? So whenever a number is not a perfect square, it is usually, and you are going to take the square root of it, then usually that number will be a irrational number. That means root 2, root 3, root 5, root of 6, root of 7, root of 8, and so on. These numbers, if you go ahead, next will be root 10. So such kind of numbers which are not perfect squares are irrational numbers. The technical definition of irrational number is nothing but numbers which are not recurring and not terminating. So non-recurring and non-terminating numbers are called as irrational numbers. So when I say roots are irrational, what do I mean by that? Let's take an example. If I give you a quadratic equation, let us say d square minus d minus 4 equal to 0. We have d square minus d minus 4 is equal to 0. Now, you must always remember whenever you get a quadratic equation might sometimes be very easily factorizable, or sometimes it may not be an easily factorizable quadratic equation. So how do I check whether an equation is easily factorizable or not? The easiest way of doing this is finding b square minus 4ac. Simply get b square minus 4ac. If b square minus 4ac is a perfect square, it will definitely be a very easily factorizable equation. And if it is less than 0, if b square minus 4ac comes less than 0, we have already seen the roots will become imaginary. And if it is greater than 0, but it is not a perfect square, listen very carefully. B square minus 4ac is greater than 0, that means it is positive number, but it is not a perfect square. Then the roots are definitely going to be irrational. So if I take this case, b square minus d minus 4 equal to 0, I am going to compare this with our standard quadratic equation a d square minus of b d minus of c equal to 0. On comparing, I get the value of a as 1, the value of b is minus 1, and the value of c ad square plus bd plus c equal to 0. So a is equal to 1, b is equal to minus 1, c is equal to minus 4. So if you try to get the value of b square minus 4ac, so b is minus 1, its square will become 1. So 1 minus of 4, a and c both of them are 1 and minus 4. So b square, which is minus 1 square, minus of 4, a is 1, c is minus 4. So that gives me minus and minus became plus, that's 16 plus 1, you get 17. So your equation was d square minus d minus 4 equal to 0, and your value of b square minus 4ac is coming 17. 17 is not a perfect square. 17 is not a perfect square. That means the roots are definitely going to be irrational roots. Let's get the roots using the formula method. We all remember the formula method. So by formula method, we already knew that the roots are given by, say d is equal to minus of b plus and minus under root of b square minus 4ac upon 2a. Let us put up the values. So I'm going to get d is equal to, d is equal to minus of the value of b. So b is minus 1. So I put minus of minus 1 plus and minus root of. You have just now got the value of b square minus 4ac and that value was 17. So I'm going to put root of 17 here upon 2 times of a is 1. So minus and minus became plus 1. Your answer is 1 upon 2 plus and minus root of 17 upon 2. Or you can also write the same thing as 1 upon 2 plus and minus root of 17 by 4. So I can compare this with alpha plus minus root of beta. Look at this, how the comparison is done. It is alpha plus and minus root of beta. Now if I want to write the complementary function of such a differential equation where the roots are irrational. Did you observe that the roots are irrational? Alpha plus minus root of beta. Beta is not a perfect square. It was root of 17 by 4. So definitely your answer is going to be an irrational number. The roots are going to be irrational. So whenever you get an irrational number, what you must be doing? How do I get the complementary function? Now this complementary function is very similar to what you have written when the roots were imaginary. I hope you should recall when the roots are imaginary, at that time the complementary function was given as e raised to alpha x, then a bracket c1 cos beta x plus c2 sin beta x. This was the complementary function when your differential equation had imaginary roots. So now when the roots are irrational, observe how the complementary function is written. One small change I am going to do, but obviously the change is very important. So the complementary function, whenever the roots are irrational, it is given as yc is equal to e raised to alpha x. E raised to alpha x, it is very similar to your roots are imaginary. E raised to alpha x, then c1 cos hyperbolic root of beta x plus c2 sin hyperbolic root of beta x. Did you notice the change? In imaginary roots we have written c1 cos beta x, cos beta x, sin beta x. In roots are irrational, we are writing cos hyperbolic of root beta x, sin hyperbolic of root beta x. Root beta was your root. Alpha plus minus root beta. The value in the number is from the root from here. So now I can write the complementary function in our case. The question that we are discussing. In our case, the complementary function is going to be e raised to alpha. So alpha is 1 by 2. So e raised to 1 by 2x, then a bracket c1 cos hyperbolic of root of beta. So that's root of 17 by 4, or you can simply write root of 17 upon 2. So cos hyperbolic of root beta x plus c2 sin hyperbolic of root of beta is root 17 upon 2 x, and you close the bracket. So that is how we write the complementary function when the roots are irrational. Now let's also discuss very quickly what will happen if the roots are going to repeat. Let us say if I give you the same question but I give you power, let's say 3. If I give you power 3. So if it is now power 3, that means this root will repeat 3 number of times. So 1 upon 2 plus 1 is root of 17 by 2 is going to repeat 3 number of times, because you are taking d square minus d minus 4 the whole cube. So if it is going to repeat 3 number of times, how do I write the complementary function? Very simple. Observe carefully how to write the complementary function when the roots are repeating 3 number of times and the roots are irrational also. So yc is equal to e raised to again alpha x. So e raised to half x. Since the root is repeating 3 number of times, I will write c1 plus c2x plus c3x square into cos hyperbolic of root of 17 upon 2x plus c4, because you already continued up to c3. So we will be continuing now from c4. So c4 plus c5x plus c6x square and sin hyperbolic of root of 17 upon 2x, and you close your bracket. So people, this is the way in which you will be doing your complementary function. Now remember, the complementary function is the most important part of getting the solution, because we already discussed that the solution comprises of 2 parts. One was a complementary function and the other one was the particular integral. But before we go to the particular integral, we have to first get the complementary function in a very proper way. So these were the 4 different methods. These are the only 4 methods in which you will be getting the complementary function. I hope you have understood all the 4 methods very properly. Make sure that you solve as many questions as you can. Thank you so much for watching the video. Have a great day.